Hi everyone. Today let's look at the LeetCode problem 2270. Number of ways to split array. You are given a zero indexed integer array nums of length n. Nums contains a valid split at index I if the following are true. So the thing is, I can split the array at an index I. The sum of the first I plus 1 elements. So that is, so if you take the index I, right, it will be I plus 1 elements, is greater than or equal to the sum of the last n minus I minus 1 elements. So this means that if I pick, for example, 4 as my ith element, then sum of the I plus 1 elements, that is 10 plus 4, 14, okay, should be greater than or equal to the sum of the remaining elements. So minus 8 plus 7. So that is minus 1. So that would have been a valid condition here. Okay. So what we need to find is, we need to find how many such valid splits are available in our given array. So as you can see here, if I take, let's take one example. If I take this array, the sum here, this is 10. And if you take this sum, it is minus 4 plus 7, so it will be 3. So this is a valid one. I could have an I split at 10. Now let's take 4. Then the sum of 10 plus 4 is 14. That is the I plus 1 elements, right? And minus 8 plus 7, that is minus 1. So that's also a valid one. Okay, but if I take all the 3, then this will be 6. Okay, 10 plus 14 minus 6, so that is, sorry, minus 8, that is 6, and on the right side it's 7. So this is not valid, because now if you see, if I combine these 3, it will be 6 and this will be 7. So it doesn't valid, it is not, the first condition is not valid. Then I cannot take this entire array, because that will not satisfy the last condition, because it at least expects one element on its right. Okay, so I think the background for the question is clear. One brute force approach would be basically calculate the sum at each point and calculate the sum of the remaining n minus 1 elements. But as you can see, that will have a very high time complexity. It will be order of n squared. So now let's see, there is another way to do this. So we can use something called as PrefixSum for this problem. So let me explain to you how that works. So now let's take this example itself. So if you see here, what I can do is, I can start with a, I'll tell you the reason why I start with a right PrefixSum. There is some, like what you can do is, we can have a right and a left PrefixSum here. Okay, let's start it once more. Okay, so if you see, now if I look at the right PrefixSum, so what I mean by right PrefixSum is, I'll start from the right and then I'll come all the way to this side. So it will start with 7, then minus 8 and plus 7 is minus 1, then this will be 3, and finally we'll come to 13. So that is your right PrefixSum. Now let's take the left PrefixSum. So that is, we start from the left and then move towards the right. So this is right to left and this is left to right. 10, 14, then this minus 8 will be 6, and finally this will become 13. Okay, now we'll start from this point. Okay, so when I start from this point, if you see here, this is my, this I could actually do it on the fly, but I just want to show you the right PrefixSum and the left PrefixSum and how this will be useful. Now if I already have my right PrefixSum, as soon as I start my array parsing from this side, okay, so let's do the array parsing and do the left PrefixSum as we go, let's do it on the fly basically. So if you see here, now the first one will be 10. Okay, and what is the right PrefixSum? So the right PrefixSum is basically, you can just take the right PrefixSum of 1. That should give me the sum of all these 3 values. Okay, so then that means 10. So let's have these as my ways to store a data point here. So if you see, 10 is greater than or equal to 3. So that means this is a valid way. Now let's jump to this data. So now 10 plus the current variable will be 14. Okay, so that was your right PrefixSum, left PrefixSum so far. Now if I just take my right PrefixSum of 2, that is I plus 1, my current location plus 1, then 14, and then compare 14 and minus 1, because minus 1 is the sum of minus 8 and 7. So if I take that one, that's also a valid case. So ways will become 2. Now let's jump to the next point. At this point, 14 minus 8, that will be 6. Okay, now is 6 greater than or equal to 7? No. So this is not a valid use case. I cannot go any further, because you at least need some elements on the right hand side. So for this current problem, 2 is the number of ways. If you use the above approach, time complexity will be order of n. You can do this in basically 2 parts, right? So basically what happens is you will iterate through that array n plus n times. So that is 2n. So that is equal to order of n. Okay. Now space complexity would be order of n. Now the question is, can we do this better? Do we even need to store this in an array? Imagine that you just calculate the right sum and just put it in one variable, and assume that this is the data point that you have on the start. Okay, and this is, so basically you have 2 variables. Okay, the left PrefixSum and the right PrefixSum. So on the first loop, you just store this entire right sum and keep it there. Okay, now if you see here, what I can do is, as soon as I take my first element and append it to my left PrefixSum, I can just subtract that value to get my right PrefixSum. So that means this will be 3. At this point, this value can be reduced to 3, and then we can just compare these 2 data points. Now I'll put it this way, because I don't want to confuse you as separate variables. So we have the total sum as 13. So when I take 10 as my left PrefixSum, then I can just subtract this 10 from this right PrefixSum to get my right hand side. So then do a comparison. Now next, let's jump to this variable. Okay, so when I'm here, what will happen is my right PrefixSum will again increase. So that means this will become 14, and I can just subtract 4 from that one for my left PrefixSum. So this will become minus 1. Okay, so this is also a valid use case. So thus you don't need to maintain an array for this solution. All that you need to do is you have to just have your right PrefixSum, and then you can on the fly keep reducing your right PrefixSum and keep increasing your left PrefixSum, and check for each I splits. Okay, so this will reduce our space complexity to complexity with right PrefixSum optimized. To optimized will be order of 1. Now let's code this up. I'm going to code. I'll do one thing. I'll code this one, the order of n solution, and then I'll come to the order of 1 solution. So what we'll do is, first we will store vector int right PrefixSum. Okay, and we'll just store it in, sorry, not 0. And what we'll do is, for auto, I is equal to nums dot size plus I not auto, this has to be int. I greater than or equal to 0 minus minus I. And what we'll do is write PrefixSum of I not equal to nums dot size minus 1. This has to be nums dot size minus 1. Okay, and if that's the case, then write PrefixSum of I plus 1 plus nums of I, or it will be nums of I. That's it. Okay, so that will be the right sum. Then what we can do is, I think I need to keep it as long because this is to actually get through LeetCode. long. Then this can be a left PrefixSum. Okay, I'll keep it much simpler. R PrefixSum. Okay. Sum is equal to 0. What we can do is, I'll just iterate through the array from left to right. I don't need to go till the last element. I can just go till the last but one element, because that is to validate the second condition. So this will be L PrefixSum plus equal to nums of I. Okay, now as mentioned here, then what we can do is if L PrefixSum greater than or equal to R PrefixSum of I plus 1, then we can tell that it's a valid way. I think I have to put a variable for this also. Way is equal to 0. Okay, and this should take care of our use case. Let's see. Let's just see. Oops. Okay, ways. Okay, looks good. But let's see. As you can see, it looks like we could optimize the memory further, as I had mentioned earlier. Now if you see here, you don't need this array. We could just store this in one variable, and I can show you how that works. Okay, now have this as equal to, I can just accumulate this here. So it will be accumulate nums of I, nums dot begin, comma nums dot end, comma 0. Okay, that is my R PrefixSum. Then what we can do is, we will when we move from right to left, what we will do is, we will add the nums of I into the L PrefixSum, but we will also, we can just subtract the same nums of I from our right PrefixSum. Okay, and if L PrefixSum greater than or equal to R PrefixSum, at that point, then it's a valid way. Let's see. Okay, 1 second. see. I think this has to do with the accumulate. There is a overflow here. So what we could do is I'll just loop this through. Size plus I. We can just sum this entire number. Let's see. Plus equal to nums of I. I think this should work. Yeah. Okay. So that's it. Thanks, everyone.